Hello, in today's video we're going to take a look at several options for building an arm on your bot that can pick up, carry, and drop objects on your game surface. The platform we're going to build on today is the Steve bot made from the Lego EV3 kit. If you haven't made a Steve bot yet, you can go back a couple of videos and follow the instructions on how to build one of these. But the cool thing about the Steve bot was it had a third motor, this medium-sized EV3 motor, that would move and actuate the front lift. And that was perfect when we wanted to take some objects that were on the plane surface and push them or steer them to different areas of the mat. And while that's pretty cool, this particular arm wasn't designed to lift or carry a payload, but just simply push or pull items on the mat. So we're going to look at some different options for building an arm that can specifically pick up, carry, and drop off objects in different areas of the game surface. Let me remind you that this lift, which moves up and down, is actually powered by a motor that moves in a rotational fashion. It goes 360 degrees. So what we had to consider as we built that is how to convert rotational energy into directional movement, in this case up and down. And if you can see, we have a series of links. We go from the rotational power of the motor and attach it to this arm, which causes the arm to move forward and backward directionally, and that pivots here, converting the forward and backward movement to an up and down movement. And you can see how that works if I move the motor back and forth. But like I said, we're going to need an arm that was designed specifically to carry a payload. So we're going to remove this arm. Just remove it from the pivot points. And we're left with a bot that's a lot cleaner on the front end. And we're going to remove the two blue pins in the back, which will allow us to free the medium-sized motor. And that's the same motor we're going to use. We're just probably going to have to reposition it on the bot. And if you're using NXT and don't have one of these small motors, then you're going to use your third large motor that you have. And regardless of whichever one you choose, they both deliver rotational power, and you're going to have to find a way to convert that into directional movement. So now that we've got the Steve bot platform ready to build on, we're going to go down to the game surface and do some experimenting. So let's get started. We'll zoom in and I'll show you exactly what I'm talking about. Okay, so in addition to your Steve bot platform and your choice of third motors, again, you can use the EV3 medium-sized motor or the NXT large motor, whichever one you have ready to use. And in addition to that, we're going to use three items that you can find at your local hardware store. We're going to use a 3-gang electrical box. We're going to use a 2-gang switch plate, and then one of these PVC compression fittings. These objects are things that you should have in your inventory kit from previous gear challenges. If not, you can go to the hardware store and pick one of these up. And basically what we're looking at today is finding a way for your robot to drop either the compression fitting inside of the box or the electrical plate inside of the box. So you've got to design an arm that can do that, and also write a program that will tell your bot to come up to the edge of the box and drop in whatever your payload is. So as you start thinking of ways to design a robot that could pick up, lift, and drop an item in, let's think about how we do that with our hands. For example, let's take a look at the compression fitting. If this were laying on the table, how would you pick it up? Well, your hand would come in, grab onto it, lift it, which is basically having to defeat gravity, and then let go, and we let gravity put it in the bottom of the box. The same thing with the plate. We would approach the plate with our hand, move it down, grasp onto it, and then hold it over the box in a way where when we let go, we let gravity do the rest. And that's exactly the way we'll think about designing an arm on the robot that will do that. So let's focus on the compression fitting first. Let me move everything else out of the way. Put this in the middle so you can see it. And I've already designed a couple of examples here. And this particular arm, I've made the exact size that will easily lift and hold the compression fitting in a way that's very similar to the way our hand would work. We would have these fingers holding it underneath the compression fitting in a way so that when we come to the box, we can just drop it in there. So this robotic arm would work very much the same way. It would hold the compression fitting, come over here, and we can turn it either sideways to dump it, or we can rotate it in a way that would let go, which would be the same thing as our wrist moving forward and backwards. The consideration though is, if you build this arm, where would it pivot to be most effective? If it were to pivot back here with the motor, that would require a great deal of strength, and then when you got ready to dump it, you can see that the pivot point would have to be very high above the box before it would even let go. We could redesign the fingers here so they're not sticking up so high, or we could redesign the pivot point. What if, instead of pivoting way back here, we had it pivot here? You can see that changes a lot. It reduces the power necessary to lift the object, and then it will also make it easier to dump out if we move the pivot point. So that's option one. Let's take a look at another option. So in this example, we use the same idea of an arm and fingers, but in this case, we've made the fingers or the hand much smaller, so it'll fit in a lot nicer. And as we rotate it with this gear, it doesn't require very much power at all to move and pivot the object. So by changing the pivot location and the length of the fingers, we can easily reduce the amount of power needed to drop the object and move things back and forth. So that was option number two. And option three is even more complex. I've built a little hand grabber, and you can see that as I move the gears rotationally, it makes the fingers open and close in a left and right direction. And it would be very easy to come in, lower the arm, turn the gear, and pick up and then release. And this particular design uses a series of pivots to convert that rotational direction of the motor into a directional force that opens and closes the fingers of the hand. And you can see, while this is mechanically pretty complex, it's very simple once you start programming to just tell this motor to go forward or backward, which would cause that to grab or release the object. And the last option I want you to consider is one that might require you to think outside the box a little bit. Up to this point, we've assumed that we're going to grab the coupler from the outside. But what if we looked at different ways of picking this object up? For example, what if we, instead of picking it up in the middle, we picked it up from either end? Or what if, instead of touching the outside of the object to lift it up, what if we touched the inside of the object and lifted it that way? I built this simple one-time forklift kind of option that again will convert this rotational direction of the motor to a pivotal or up and down motion of the tine of the forklift blade. So you could come in, insert the blade of the fork, and lift the compression up and down that way, letting you either raise or lower the compression fitting based on that. And then when you came here, you could lower it and release it that way. So again, this fourth option just required you to think outside of the box a little bit. And I'm sure you'll think of even more options as you and your teammates get together. Okay, so part one of this challenge involves you taking this compression fitting from your bot, moving in a straight line, approaching the electrical box, and dropping that compression fitting in there. The good news for this challenge is that you can preload this object on your bot. You don't have to design an arm that's going to pick up, carry, and drop, because you can preload the coupler on there. All you're going to have to do is build an arm that will allow it to carry and then drop once it gets there. So for example, we'll go back to this option here. You'll just need to find a way to mount this high enough so that when you approach the electrical box, the arm extends over the top and is able to deposit the compression fitting inside the box. So you just need to carry the compression fitting in a way so that the lowest part of your arm is high enough to reach over the top of the electrical box, move the motor in a way where it will drop off the payload and then back up. And in the same way, if you chose to use an arm that has articulating fingers, you'd have to build it in a way that once you've preloaded the coupling on there, that the lowest part of the mechanism is higher than the electrical box, so that when you choose to let it go, gravity will take effect and pull it straight down. So I mounted one option arm here to the side of the brick, and I've already tested to make sure that when I've pushed up against the box down below, that this arm extends far enough in front of the bot where it will deposit the compression fitting. So I know that's going to work. So just keep in mind that this gear has represented the motor, and what I will do is remove this and install a motor. And remember, you've got two options. You can use the EV3 medium-sized motor or the NXT large motor. Regardless, you're going to have to find a way to attach the motor to the axle and then mount the motor to the brick in a way where it's not flopping around, or so that it's not interfering with the compression fitting. For example, if I were to mount this here, I'm going to have two issues. I'm going to have a motor that's moving up and down that's not fastened, and also it's not going to allow the compression fitting to rest because the motor is in the way. In the same way, I could simply attach this medium-sized motor to the end, and so it's not supported at all. And when I combine the weight of the motor with the combined weight of the compression fitting, I have here something that's not very stable, and I doubt that it's going to work very well. So that's going to require some engineering. And if you think about it, if I were to put power to this motor, the motor would just spin in place, wrapping the cable and causing a lot of problems down the line. So this is going to take some engineering to avoid any of those problems. So next, let's take a look at this forklift blade that I've mounted on here. You can see that I've got that rotational motion converted into directional at the front. I've double checked and I know that this is going to be tall enough to fit over the end of here. So if I preload the compression fitting on here, I can already feel some resistance coming from the motor. You can see that here. And what I'll need to do is put some friction on the motor to not let that drop. And I think right here you'll see the first problem is if I'm carrying this with the forklift blade, I'm going to have to approach the box not from this direction, but from the long end. And the next problem is the way I've built it, it won't drop far enough down the blade to release the compression fitting. Gravity's working on it, but it's not letting it go. If I chose to invert this blade and mounted it this way, that once I release the motor, it's going to go ahead and fall off of that way. So again, that's another option. And if you chose to do that, then you just have to find a way to get whatever motor it is that you wanted to use mounted to control this. Okay, I realize this is a pretty good challenge. The weight of this compression fitting and the size of it, I think is going to give you a pretty good challenge when you try to think of ways to carry and drop it. And even more challenging for part 2 is going to be doing the same thing for this switch plate. You'll have to find a way to carry it to the box and then find a way to let go of it and let gravity take it to the inside of the box. Okay, so just to recap the challenge. For part 1 of this challenge, you need to carry and drop this compression fitting into the electrical box. Remember that it's okay to preload this in your robot before you hit go. And part 2 of the challenge is the same, except you're carrying and dropping off this switch plate. I think both of these items will give you 2 different sets of problems to solve. As far as programming for this challenge, we're going to keep things as simple as possible. All you need to do is make sure you've preloaded the compression fitting or the plate onto your robot, and once you hit the start button, all that your bot has to do is move forward in a straight line, approach the blue electrical box, stop, and then drop its payload into the box, and then be able to pull back away from the box without touching. Alright, I feel like I've given you enough to keep you busy for a while. Hope you enjoy the challenge. Hope you're able to think outside the box, and above all, have fun with it.